Okay, so thanks, Alex, and thanks for the invitation to talk. So I thought I've been asked to talk a little bit about some kind of future ambitions, and Adrian has touched on these a bit in his talk. So I thought I'd talk a little bit about how UKCA works now, what the changes are that are being made at the moment, and what we'd like to be able to do with UKCA in the future. So at the moment, what can you do with UKCA? So it runs within the unified model, and it runs stably at many different versions. It runs from the head of the trunk, so you can always have a working version when a version is released, but often things like UKSM1 are earlier versions, and there are still versions being used at kind of 7.3 and 8.4, but they all are consistent across those different model versions. It runs on various platforms. It runs on Archer, it runs on Monsoon, it runs on the Met Office machines, it runs in Australia and New Zealand. It runs in a virtual machine, so you can test things out on your desktop at home or in work. It can run at different resolutions, so these are kind of climate type resolutions, M48 and 96. It has different levels. You can run in different configurations, so atmosphere-only configurations, coupled configurations, and regional configurations. And we've heard some really great talks over the past couple of weeks about work done at these different configurations and different resolutions. It can sort of be run in a standalone box model with a lot of work, and I'll talk about that in a little bit. And it doesn't work with Elfric at the moment, as Adrian has covered. So what is Elfric? So Elfric is the Met Office's next generation model. It's built around a completely different dynamical core. And what's happening is the physics routines, of which UKCA is one, are going to be included to enable a kind of full GCN to be constructed. And so there's a lot of technical work going on throughout the whole of the to enable these routines to run. It's part of the development process. You have to be able to run Elfric as well as the and it's still a work in progress, but as Alex pointed out, within 5 years it will be the model that will be running. And at the moment, from an Elfric technical perspective, the way UKCA is built and coupled into the is a problem. And so this is this API that Adrian mentioned. So how does UKCA couple to the I didn't want to go into a lot of detail, but essentially for most people who use UKCA, this green box here is what you're used to dealing with. So if you're adding in chemical reactions or tweaking the aerosol or something like that, you're going to be playing around in this green box. You're adding in emissions, you're changing things. This green box is what happens. And from a technical perspective, we have the and UKCA is kind of sitting within the and data is passed into UKCA via these red sections here, which is this API, or the old API that the UKCA had. And I didn't want to go into a lot of detail. I just wanted to say that here be dragons in these particular bits. There was a lot of good sense as to why it was written as it was in the past, but it's rather technical and rather difficult to manage. And so what the large amount of work that John Hemmings and Mohit and Neil and people have been doing is to make what appears to be on this rather simplified plot, a small change, which is to move these hideous parts out of UKCA. And essentially the horrible bits are still contained within the and then what happens is they're kind of reformatted into nicer ways that UKCA can then read. So from a user perspective, and even most developers' perspective, you can carry on in this green bit, and all that's happened is these red bits have moved to the side. And what will this then allow us to do is to take the UKCA section completely and put it into Elfric. And here, there are no horrible red bits. There is no dragons, there's no problems, hopefully, and it will allow UKCA to run within the Elfric system. And so what would happen is the UKCA code, it sits within the code at the moment, but Elfric just takes that directly from the code and would run with it. And so there's a lot of work going on for the aerosol, as Adrian has talked about, and also there's a similar kind of parallel work package being developed for the chemistry side as well. And from your perspective, from a user perspective, if you're running UKCA, then this doesn't really mean very much to you. The model will still run at all versions. It probably won't even change results for the work that's gone on. You know, the closed release that occurred a couple of versions ago that Adrian mentioned, you know, that didn't change results. It's been done really well by the people that are working on it, and it's allowing these large structural changes to take place with minimal kind of user impact. If you are developing UKCA though, you'll have noticed extra steps. So when you're adding kind of a new input that you might have in rows, or new input fields coming from somewhere, it's a bit more complicated now, because rather than, you've got to, as well as doing kind of the old method, you've also got to build in the new method as well. When UKCA moves over to Elfric, it'll just be the new method, but there's this kind of, at the moment, there is this process of having to have both of these working consistently. But what does it mean? What will this allow us to do? So one thing that could work pretty easily is you could run the same configuration in the UM and in Elfric, which is good from an Elfric perspective, it's good from a UM perspective, and it's good from a UKCA perspective, because it allows us to test some questions that, say, James was mentioning earlier about model biases. You know, Elfric might have a very different structure. How does that affect the chemistry when we run it in these two different models? We can sort of look at this with nudging, but it will allow us to explore those sorts of things in more detail. And it could potentially allow UKCA to rerun on its own or with other models as well. And so standalone UKCA is kind of one of our very high priority things that we want to do. As I mean, standalone models are really useful. So this is some work that we did a couple of years ago that was done by Scott Archer-Nichols, where we were looking at improvements to the UKCA chemical solver to try and speed it up. And we were able to run these improvements in a standalone model as well as running them in the global model. So we could look in much more detail about what these did on a time-step by time-step basis within the solver, and as well as being able to then look at these on a kind of more global scale. But there are problems with this. So we can't do this routinely. So there was a large amount of work that was done by many people to make standalone models in the past. People have made models for particular versions. You have to take the code out. You have to spend time getting the code to work in a standalone configuration. And as you're doing that, you know, the main UM is still progressing through its versions. People are still making developments to it. If you were to have a parallel development process where you had to manually take these developments and put them in the box model again, it would almost be unworkable. But it would be unworkable. So these this box model here that was used, I think was a version 10. The main work that was done in the UM was at version 10.7, which was, you know, 3 years later. And so at some versions there might not be many differences, but with the work that's gone on the API, with work that Olaf had done to kind of improve how the chemistry is defined, the box model that was used for this work is now very different from the way the structure of the UKCA code is on the UM trunk. And this means that it's not really a tool we could use anymore. We would like to be able to use it, but it's actually more work to keep using this than it would be to start afresh. So what would we, you know, in our ideal situation, what might we have? So we've got our UM, and we've got Elfric, we've got the UKCA code, and it works in both. And we could have also our UKCA code in a box model, and we could have all these three running at the same time. So you would do initial developments in the box model, develop, you know, maybe technical developments, maybe looking at new mechanisms, something like that, changes to the aerosol scheme, and you can test it out in the box model before you then apply it to the UM or to Elfric or to both. But of course, this opens up possibilities for us. We could also put UKCA into a chemistry transport model. So obviously, Tomcat Slimcat are very similar to UKCA. They started off in the same place. Maybe we could couple it back into there, and then we could, rather than having to run more complex GCM, we could run an offline model, and we'd be able to, isolate things. And there's loads of great stuff that can be done with GlowMap, offline GlowMap. We'd be able to do similar things with the chemistry in that sense. But we'd have the advantage that, anything we learn, we can directly apply to the straight away because it's taking the code from the same place. And by extension, there's lots of other types of models we could couple into as well. So a single column model, or 2D model, or trajectory following model, all of these have different applications and use cases. They're different ease of use. We might be looking at something where a single column model is more appropriate to look at. So exoplanets or something like that. We might want to look at lots of ensembles of a 2D model. You might want to say for aircraft campaigns, run a trajectory following model. And everything that you learn can be put back into the UKCA code and applied to bigger models or to other models in the hierarchy of models that are here. So there's lots of great work that could be done with UKCA at its core with all these different models that are there. So what, as a user or developer of UKCA, this would have a lot of benefits for you. You'd be able to work with UKCA without needing to use a large global model. So, for undergraduate projects, for instance, it's great to give them UKCA data, but asking people to run the as an undergraduate project is just usually out of the time that's allowed. But you could give them a box model or another smaller model, and you could get a load of great work out from there. And similarly with PhD projects, you don't have to dive straight in with the global model. You'd be able to work on these smaller models first. If your main interest is mechanism development, for instance, you do that in the standalone model, and then you could then move up to the global model, and you won't need to recode everything. So at the moment, if you want to work in a box model, again, because this other model we had is out of date, often people use a different model and then have to recode everything again. You wouldn't need to do this here. You do the coding once, and then it's merely a matter of applying it to these different models. From a UKCA perspective, it has lots of kind of benefits from a technical point of view. So we could have UKCA in its own repository. We can have a different release process to the or to Elfric. I'm not saying we will, but it might be something that we could have. We might have allow us to have maybe an annual cycle or slightly different coding practices or development process. And we could even have a different license arrangement, which could widen the user base. So JULES, for instance, has a slightly different license arrangement to the So all of these are things that could happen with the UKCA out of the and with this hierarchy of configurations, it facilitates this pull through of community developments. So people can work on schemes in a standalone model and in say the CTM, and then these could be taken and implemented later in other configurations, but with less work because everything's done in the same system. And because we've got more uses, we might have more users, we have more science going on, and this benefits the model as a whole. More users means that as well as more things being added, more bugs are found. These are fixed for everybody, and everybody benefits from having a system like this. So the progress that's been going on. So the rewrite of the UKCA coupling is progressing. So many changes were made of the mass versions, as Adrian mentioned. And I think this has been a really great amount of work that's been done, and really successfully. And there's still more to be done, but we can start to see the light at the end of the tunnel, and allow us to really start using this very soon. We have a well-developed plan for the creation of a standalone model. We've worked on this for a while, and we're just trying to get everything into place to allow this work to start. And it's, once that's there, that will be available for everybody to use straight away. And because we can use the UKCA in a virtual machine, you could install that easily wherever you are. We've had some early discussions regarding coupling UKCA into Tomcat Slimcat, and also potentially coupling into NAME as well for other use cases. So there's lots of work on some aspects. Other aspects, are merely possibilities that we might be able to do with it. So if you would like to be more involved, be involved, then do let me know. And also, as Alex has mentioned, the UKCA user survey is a really good thing for people to fill in to allow us to get an idea of how people are using UKCA, and what what you think is good, what you think is not so good about it. And we can start thinking about these things. I mean, we think about these things all the time, and we want to be able to incorporate these to make UKCA better for everybody. And that's it. Thanks very much for listening.
Thank you, Luke. Excellent timing. So, as ever, we can go to the Google Doc for some questions, and we've got a question being live typed. And so the question says, great stuff. How about things like deposition, which are planned to go into JULES?
So yes, so deposition is planned to go into JULES, and that would allow us to have more, to make use of the JULES framework more in terms of how deposition is done. As with all things coupling into other models, you have to make choices about how things are made. So we will have to have simplified schemes for deposition if it's into other models without JULES in there. Mm-hmm. At the moment, obviously deposition is still done within UKCA, and that will continue. It won't be taken out until we're able to run without it. It may be that deposition, for instance, still stays in some form, but it's tidied up a lot more, certainly.
Yeah.
Similar to the lightning scheme, for instance. So allowing the lightning to be run within the allows a greater amount of flexibility and improvements to representation, but we still would need to have a lightning scheme in UKCA to a certain extent.
That's great. And do you have any idea of the timelines for some of these changes? I mean, obviously Adrian has also talked about the tickets which have, been completed. So some of this, really is work that's been done, and some of this is work to be done. But in terms of this sort of standalone capability, what's the?
I think it would take 18 months to 2 years to make a standalone model. Okay. Once we start to make it properly. Because from working on the standalone model previously, that's kind of what the timeline was. Earlier versions for maybe just the chemistry could be done a lot sooner, but to have everything working as we would like in a system that we would like would take about that long.